Ever look at a circuit board and wonder, like, how do all those tiny little components make our gadgets do all the amazing things they do?
Yeah.
It's kind of mind-boggling. Well, get ready, because today we're going on a deep dive into one of the biggest secrets of modern tech, transistors.
Oh, yeah. Transistors, they're everywhere, but most people, I mean, they have absolutely no idea what they are or how they even work.
Right, but they're essential, like the backbone of our whole digital world.
Totally.
So to help us unlock this mystery, we've got a fantastic YouTube video called Fun with Transistors. It's from the Hack Make Mod channel.
Oh, I love that channel.
Me too. The creator is all about DIY and hands-on learning, which is, perfect for how we like to do things here.
Absolutely. I mean, the video actually takes you through building simple circuits from scratch, which is such a good way to really grasp those concepts.
Yeah, for sure. It's like having your own mini electronics lab right in your own home.
Exactly.
So no more head scratching when you see a circuit board.
Yeah, no more.
Let's get right into it. Let's start with the basics. What is a transistor? And, why should we even care about these things?
Okay, so think of a transistor as this tiny little gatekeeper for electricity. It can either completely block the flow, acting like an off switch, or it can amplify a weak signal, making it much stronger.
Okay, I'm starting to see how this is important.
Yeah, I mean, that's why they're crucial to, pretty much everything. Smartphones, spaceships, you name it.
Wow. And the video kicks things off by showing us this in action, right? Building a simple circuit using an LED.
You got it. It's a basic LED circuit to demonstrate how a transistor can act as a switch, turning the LED on and off. It's a really great visual to start with.
LEDs. Those
Yeah.
tiny little lights are everywhere these days.
Mhm.
But I have to admit, when I first started playing around with electronics, I always struggled to figure out, which leg of the LED was positive and which was negative.
Oh, yeah, that can be tricky.
Yeah.
Well, actually, the video gives some really good tips for figuring that out.
Oh, cool. Like what?
Well, the longer lid is usually positive.
Oh, okay. Yeah.
And then also look for a flat spot on the LED casing. That's usually on the negative side. Just little things like that, can save you a lot of frustration when you're building circuits.
Totally. Those little details are so important. So we've got the transistor acting like a simple switch, but things start to get a bit more interesting when they introduce the concept of an inverted circuit.
Yeah, this is where it gets kind of mind-bending.
Oh, great. I love mind bending.
Yeah. So in an inverted circuit, when you activate the signal, it actually turns the LED off.
Wait, what? Really? That seems like totally counterintuitive.
It does.
Why would we want that?
It's basically a clever way to show how a transistor can also control the flow of electricity by diverting it to ground. It's basically shorting out the LED.
Oh, okay.
Yeah, it's a really good way to show how versatile transistors are.
I'm starting to see how this works. And they actually build this on camera in the video, right?
They do. They show you, step by step, how to make the circuit. And they demonstrate how pressing a button, which activates the transistor, causes the LED to go dark.
That's awesome.
Yeah, it's a really effective way to just show the concept in action.
Totally. Okay, so we've talked about the transistor acting like a switch.
Yeah.
But we haven't talked about, the three legs it has. The collector, the base, and the emitter. These always kind of mystified me, I have to admit.
Yeah, it's a little bit like a water pipe with a valve, right?
Okay.
The collector is where the water flows in. The emitter is where it flows out. And then the base is like the handle that controls how much water goes through.
Oh, that's a great analogy. So if we apply a small voltage to the base, that's like turning the handle, which then controls a much larger flow of current between the collector and emitter. It's amplifying the signal.
You got it.
Yeah.
And just like, you wouldn't want to crank the handle on a water valve too hard. You need to protect the base of a transistor with a resistor just to limit the current flowing into it.
Right, that makes sense. I remember in the video, they really emphasized how important resistors are for protecting all the different components.
Yeah, it's super important.
It's like they're safety valves for our circuits.
Yeah, you could say that. Even when you're just working with simple circuits, understanding these fundamental principles is crucial. It's not just about connecting the dots. It's about understanding why things work the way they do.
Yeah, totally. So we've seen how a single transistor can act as a switch and control the flow of current. But the video takes it a step further and combines transistors to create something called an oscillator.
Oh, yeah.
Now things are getting really interesting.
This is where you start to see how these simple components, when you put them together, can create really complex behaviors.
I was so fascinated by how they showed this visually in the video.
Mm-hmm.
First, with LEDs blinking, and then by actually making it audible with a speaker. It was so cool.
Yeah, I love that part. Visual and auditory feedback are so powerful, especially when you're trying to understand how circuits work.
So how do they actually create this oscillator? I remember there were 2 of those inverted circuits involved, right?
Right, so they took 2 of those inverted circuits, each one controlling an LED, and they connected the output of one circuit to the input of the other.
Ah, so they basically created a loop.
Exactly, and this loop created this like continuous back and forth switching between the 2 circuits, which is essentially what oscillation is.
Okay. But in the video, they showed that initially this switching was happening super fast. So fast that the LEDs just seemed to stay on.
Yeah.
They had to add a delay to actually see the effect.
Yeah, exactly.
Yeah.
They used a resistor and a capacitor to kind of slow down the rate of voltage change, and this allowed you to see the LEDs actually blinking on and off.
That's so clever. It's like adding a timer to the circuit.
You could think of it that way.
And then, boom, they swap out one of the LEDs for a speaker, and suddenly that blinking becomes this audible tone.
They love that.
It was such a brilliant way to show how the same electronic principle, can create both visual and auditory effects.
For sure. And this concept of oscillation, this rhythmic back and forth switching, it's actually at the heart of so many devices we use every day.
Wait, are you telling me that something as complex as, like, a computer relies on the same principle as a blinking LED?
In essence, yes. Clocks, computers, radios, they all use oscillators to function. They depend on this precise timing to keep everything in sync.
That's incredible. It makes you realize how powerful these simple building blocks really are.
Totally. And the video, it doesn't just show you how to build the oscillator. It also explains how it works using schematics, which are like roadmaps for circuits.
Yeah, those schematics can look pretty intimidating at first. But once you learn all the symbols, they really do help you visualize how the circuit is connected and how the electricity is flowing through it.
For sure, for sure. They're like a language you need to learn to really get electronics. And the video does a great job of walking you through each part of the schematic, explaining how the transistors, the resistors, the capacitors, and the LEDs are all working together.
Yeah, it's really well done. And I love how they showed how just changing one component, like a capacitor, could change the frequency of the oscillator, making the LEDs blink faster or the speaker's tone higher.
Yeah, that's really cool.
It's like having a hands-on control panel for your electronics. But what's even cooler is that this oscillator, built with just a handful of components, is like the basis for so much of modern technology.
It is. It's amazing.
Wow, that's mind-blowing. It's like we're starting to crack the code of the electronic world. We've gone from a simple switch to a circuit that can generate a continuous signal. What comes next?
Well, now that we can create a signal, it would be nice to control it, right? Like to be able to turn it on and off when we want. And that's where the SR latch comes in.
Ooh.
And the video explains it in the super clever way using popsicle sticks and marbles.
Popsicle sticks and marbles. Okay, now I'm really intrigued.
Yeah, it's a great visual. So the SR latch, it's like this memory element. It can hold a state, either on or off until you tell it to change.
Wow, so that's how we start getting into memory, right?
Yeah.
Okay, I can't wait to hear more about this in part 2 of our deep dive. This is getting good.
Definitely. We'll see how those popsicle sticks and marbles work.
I'm excited.
All right, so are you ready to dive into these SR latches?
I am. That popsicle stick and marble analogy from the video, I gotta admit, that really got me curious.
That's pretty neat.
It is. It's cool how they can explain, these kind of complicated electronics concepts using such simple stuff.
Yeah.
But I'm still kind of wondering, like, how does it actually work, with the transistors?
Okay, so imagine you have like 2 light switches,
Okay.
but they're wired in a kind of special way.
Right.
One switch turns the light on, and then the other one turns it off. But here's the thing. They lock in that state
Oh.
until you flip the other switch.
So it's kind of like a toggle switch, right?
Exactly.
But instead of just one switch, you have 2 inputs that control whether it's on or off.
Exactly, you got it. So in an SR latch, you have these 2 inputs, and they're called set and reset. Activating set turns the output on, and then activating reset turns it off. And the cool thing is, it stays that way, even after you remove the input signal.
Ah, so that's how it remembers.
Yes.
It's like this, really basic form of electronic memory.
Exactly, precisely. And to show this, in the video, they add buttons to the SR latch circuit.
Oh, cool.
Pressing one button sets the latch, and that lights up a green LED, and then pressing the other button resets it, and that turns on a red LED. So you can really see it happening.
It's awesome. I bet that was really satisfying to see work.
But then, didn't they connect this SR latch to the oscillator we were talking about earlier?
Yeah, they did. That's where things get really, really clever. So now we have this continuous signal coming from the oscillator, right?
Right.
But then the SR latch gives us control over whether that signal can get through or if it's blocked.
So you can, like, turn the oscillator on and off using the button?
Yeah. That's pretty cool.
Yeah.
But I think I remember they couldn't just connect the two circuits directly. Wasn't there something about a diode?
Good memory, yeah. So the thing is, without a diode, the output from the oscillator could actually feed back into the SR latch.
Uh-oh.
And that could mess things up and make it do unpredictable stuff. The diode makes sure that the signal only flows in one direction.
So it's like a one-way gate for electricity, preventing any kind of backflow that could cause problems. It's crazy how such a tiny component can be so crucial.
I know, it's amazing, right? It's pretty common in electronics. Sometimes it's these seemingly small little details that can make all the difference. And it's really cool that the creator explains not just what they're doing, but also why they're doing it.
Yeah, definitely. That's what makes this video so great. It's not just like a recipe to follow. It's about really understanding the principles behind it all.
Yeah.
But they didn't just stop at building the circuit, did they? They showed some real-world uses for this combo, right?
Sure, they did. This is where we see the theory come to life, right? So they demonstrated using a photocell, it's a light-sensitive resistor to trigger the oscillator when it was exposed to light.
Oh, yeah, I remember that. They connected the photocell to the set input of the SR latch.
Yeah.
So when the light hit it, boom, it triggered the oscillator and made the sound.
Yeah.
It's like a DIY light alarm.
Yeah, exactly.
Yeah.
And then they took it even further by showing how a thermistor, which is a temperature-sensitive resistor, could be used to trigger the oscillator, but this time based on changes in temperature.
It's amazing how you can take these simple sensors, combine them with these transistor circuits, and suddenly they can do all these cool things.
Yeah, it really shows you just how versatile transistors are. You start with this basic component, and then with some clever design, you can build systems that can react to the world around them,
Yeah.
in all sorts of really useful ways.
This deep dive is really giving me a whole new way of looking at how electronics work. It's like we're peeling back all these layers of complexity and seeing that there's this elegant simplicity underneath it all.
Yeah, that's a great way to put it. And what's really great about the video is that it encourages people to try this stuff themselves,
Totally.
It makes electronics seem much more approachable, even if you're just starting out.
For sure.
Oh.
Speaking of which, I love how the video ended with this challenge to the viewers.
Yeah.
They showed how to create visual and audible outputs, with the LEDs and the speaker.
Yeah.
But they left us with a question. What other kinds of sensors could you connect to this system? What other cool practical applications could you create?
It's a fantastic invitation to just explore and experiment. I mean, the possibilities are really limitless, It just comes down to our imagination and ingenuity.
I think that's a perfect place to wrap up part 2 of our deep dive. We've gone from a simple switch to an oscillator, and now to a circuit that can actually remember its state and interact with the world around it. Who knows what amazing things we'll discover in part 3.
I'm excited to find out.
All right, so we're back for the final part of our deep dive into the world of transistors. We've come a long way, right, Shirley?
Yeah.
From those simple little switches to oscillators to even circuits that can remember what state they're in. It's amazing to see how much you can do with these tiny components.
Yeah, it really is. The Fun with Transistors video did such a great job of breaking it all down and showing just how powerful transistors can be.
Definitely. I feel like it's really opened my eyes to a whole new world of possibilities.
Oh, yeah.
But before we wrap up this deep dive, I'd love to hear your thoughts on the bigger picture here.
Yeah.
We've seen how transistors can be used to build oscillators and logic circuits, and they can even interact with all these different sensors. What does this mean for technology in general? How does this stuff impact our everyday lives?
That's a really great question. I mean, think about it. Pretty much everything in our digital world, smartphones, computers, cars, even medical devices, it all relies on transistors.
Yeah.
They're literally the building blocks of modern electronics.
So understanding how transistors work is understanding the core language of technology, wouldn't you say?
You got it. And what's so fascinating is that the basic principles we've been talking about, switching and amplification and feedback, these are things that can be applied on a much larger scale. You can go from a simple little LED circuit all the way to a microprocessor that has millions of transistors on it,
Wow.
all built on the same fundamental ideas.
It's like learning the alphabet and then suddenly realizing you can write whole novels with it.
I love that analogy. That's a great way to think about it. And what's even cooler is that, like, the whole field of electronics is always moving forward. We're seeing smaller and faster and more energy-efficient transistors being made all the time.
That's so cool.
Yeah.
So it really does feel like the possibilities are endless. I'm starting to see electronics as like less about circuits and components and more about, creative problem solving. Like you have this set of tools, these building blocks that you can combine in like an infinite number of ways to create new things and solutions that we haven't even thought of yet.
Absolutely. That's the beauty of it. And that's why, I think it's so important for everyone to have at least some basic understanding of how electronics work.
Yeah.
It's not just for like engineers or scientists anymore. It's like essential knowledge for the 21st century, really.
Totally. This deep dive has definitely made me want to learn more. I might even try building some simple circuits myself just to see what I can do.
I highly recommend it. It's so rewarding. And, if you're feeling inspired, definitely check out that Fun with Transistors video. It's a really fantastic place to start. The explanations are so clear, and the instructions are easy to follow.
Definitely. It's a fun and engaging way to get into transistors and start experimenting.
For sure.
Who knows? Maybe it'll even inspire some of our listeners to come up with the next big tech breakthrough.
You never know, right? The world definitely needs more people who are curious about electronics, tinkering around and exploring all the possibilities. Because, the future's built on innovation.
That's a great point. I think that's a perfect note to end on. A huge thank you to you for sharing your insights and expertise with us today. It's been awesome.
It's been my pleasure. I always love talking about transistors.
And to our listeners, if you're feeling inspired to delve deeper into the world of electronics, check out the Fun with Transistors video. Happy exploring, everyone.